What if the real key to staying strong, energetic, and independent after 60 is not found in chia seeds, flax seeds, or trendy plant powders, but in a single, often overlooked food that directly feeds your muscles, your mitochondria, and even your longevity? Because here is the truth after 60. The body does not just age, it adapts. It becomes more resistant to building muscle, more sensitive to inflammation, and less efficient at using the protein you eat to repair tissue. And that is where the silent disease of sarcopenia begins, the slow, gradual loss of muscle mass and strength that can steal independence, vitality, and even lifespan. Now, here is the surprising part. Many people, in their attempt to eat healthy, start replacing protein-rich meals with chia puddings, smoothie bowls, or seed-based breakfasts. Chia seeds are wonderful for omega-3 fats and fiber, but when it comes to stopping sarcopenia, they simply do not deliver what your muscles are begging for. The muscle fibers of a 65-year-old are not the same as those of a 30-year-old. They require a much higher signal, a stronger anabolic stimulus to trigger growth, and that stimulus begins with one molecule, leucine. Leucine is not just an amino acid, it is a molecular switch that tells your muscle cells build, repair, grow. But the foods richest in leucine are often the ones that get unfairly avoided, foods like eggs, salmon, sardines, and the one we will be diving into today: whey protein isolate, derived from high-quality dairy. This is not just a gym supplement. It is a clinical tool, proven in dozens of studies to reverse muscle wasting, improve mitochondrial biogenesis, and extend functional lifespan. Here is what is happening at the cellular level. As we age, the mTOR pathway, that is the mechanistic target of rapamycin, becomes less sensitive. Think of it like a dimmer switch that no longer lights up fully when you flip it. To activate it again, you need a higher threshold of leucine-rich protein in a single meal, not small amounts spread across the day. That threshold is roughly 2.5 to 3 grams of leucine per meal, something you simply cannot reach with chia seeds or greens alone. And this is where the research gets exciting. Clinical studies from the Journal of the American Geriatric Society and the American Journal of Clinical Nutrition show that older adults consuming around 30 grams of high-quality protein per meal, especially from sources rich in leucine, not only preserve muscle but actually regain it, even in their 70s. That is regeneration, not decline. If you ask most people over 60 how much protein they eat in a day, they will often say, "I get plenty. I have a bit of yogurt for breakfast, a sandwich for lunch, and some chicken for dinner." And yet, when we look at the data, muscle mass still declines, strength continues to fade, and energy drops year after year. Why? Because the issue is not total daily protein. It is the distribution and the quality of that protein, especially the leucine content per meal. Here is what is happening at the cellular level. Inside your muscle fibers, protein synthesis is regulated by a molecular switch called the mTOR complex. Think of mTOR as the command center that tells your cells to either build or break down muscle tissue. To activate it, you need a strong enough signal, a signal triggered by the essential amino acid leucine. In your 20s, that signal is easy to achieve. Even small amounts of protein turn on muscle building efficiently. But after 60, this sensitivity declines. Your body becomes what scientists call anabolically resistant, meaning it needs a louder signal to get the same effect. Research shows that older adults need approximately 2.5 to 3 grams of leucine per meal to maximally stimulate muscle protein synthesis. To put that into perspective, you would need about 150 grams of chicken breast, 4 large eggs, or a single scoop of high-quality whey isolate. Now compare that to the average breakfast of oatmeal, fruit, or chia pudding. Those meals typically provide less than half a gram of leucine, far below the threshold. It is like flicking a light switch that is not connected to any power source. This explains why older adults who eat light meals or small snacks throughout the day still lose muscle, even if their total protein intake looks adequate. The signal is never strong enough to turn on the machinery of growth. Let me break this down with a simple example. Imagine your muscle protein synthesis as a factory line. In your 20s, the workers respond immediately to a soft bell that is your youthful sensitivity to amino acids. But as you age, those workers become sluggish. They need a louder, sharper bell to start production. That bell is leucine. Without enough of it, the line stays idle, and muscle repair never gets going. A study published in the American Journal of Clinical Nutrition demonstrated that older adults consuming at least 30 grams of high-quality protein at each meal experienced a 30% higher rate of muscle protein synthesis compared to those spreading smaller amounts throughout the day. This shows that how you eat matters just as much as what you eat. Here is what this means practically. For breakfast, skip the chia pudding. Instead, try a whey protein shake blended with a handful of berries and a teaspoon of cacao powder. For lunch, combine animal and plant proteins, perhaps lentils with salmon or eggs with vegetables. And for dinner, include a generous portion of fish, chicken, or tofu, paired with micronutrient-rich sides like spinach and avocado. And if this breakdown is resonating with you so far, go ahead and press the subscribe, because this is the kind of deep, evidence-based science that truly changes how we age. The takeaway here is simple, but powerful. Your muscles do not fade because you are aging. They fade because the signal to grow is not being heard. Once you cross that leucine threshold consistently, you reignite the factory and your body starts building again. When most people hear the words whey protein, they picture bodybuilders at the gym, plastic shakers, and muscle mass that seems irrelevant to the everyday person. But here is what science tells us. Whey protein is not just a fitness supplement. It is one of the most potent nutritional tools for protecting muscle mass, improving metabolism, and extending health span in older adults. Whey protein is derived from milk during the cheese-making process. What makes it extraordinary is its amino acid profile. It is exceptionally rich in branched-chain amino acids leucine, isoleucine, and valine, and contains the highest leucine content per gram of any known protein source. This is what allows it to activate the mTOR pathway faster and more completely than nearly any food we eat. Here is what happens at the cellular level. Once you consume whey protein, it is digested and absorbed quickly within about 30 to 60 minutes. This rapid rise in plasma amino acid levels acts as a metabolic signal. It triggers muscle protein synthesis and simultaneously suppresses muscle breakdown. It is like switching your body from a catabolic, breakdown mode into an anabolic, build mode. Now, beyond muscle building, whey has remarkable systemic effects that go far beyond its reputation. Studies from journals such as Nutrients and Frontiers in Aging have shown that whey protein supplementation in adults over 60 leads to measurable increases in lean body mass, grip strength, and walking speed, the three key indicators of physical independence. But the story does not stop there. Whey also influences mitochondrial function. It contains cysteine, which boosts the body's production of glutathione, your master antioxidant. Glutathione protects your mitochondria from oxidative stress, the same type of damage that drives aging and cellular fatigue. When you improve mitochondrial efficiency, you do not just build muscle, you build energy. You move better, recover faster, and feel sharper. Let me break this down with a simple example. Think of your mitochondria as engines inside every muscle cell. When they are protected and well-fueled, those engines run clean and powerful. But with age and chronic stress, they get rusty. Whey protein, through its leucine and cysteine content, helps clean those engines, restoring their spark. That means better energy, better movement, and more vitality. Another fascinating benefit is the effect on blood sugar regulation. Whey protein has been shown to improve insulin sensitivity and reduce post-meal glucose spikes, a critical factor since insulin resistance is closely linked to sarcopenia and metabolic decline. That means every serving of whey is not only feeding your muscles, but also calming the inflammation metabolism loop that drives aging. Now, not all whey is created equal. Many commercial products are filled with added sugars, artificial sweeteners, and low-grade concentrates that are harder to digest. What older adults benefit most from is whey protein isolate. It is 90% pure protein, lactose-free, and rapidly absorbed. A simple starting point? Aim for one serving around 25 to 30 grams of whey isolate per day, ideally post-exercise or as part of breakfast. Combine it with a source of polyphenols like blueberries or cacao to enhance antioxidant defense, and you have a powerhouse anti-sarcopenia meal. If you are enjoying this breakdown, consider subscribing. I post weekly deep dives into longevity science, and together we can change the way aging is understood and experienced. So the takeaway here is this. Whey protein is not a gym food. It is a longevity food, one that communicates directly with your muscle cells, mitochondria, and metabolism to keep you strong, resilient, and biologically younger. If you want to understand why some people stay vibrant and strong in their 70s while others feel exhausted and weak by 60, you have to look at one thing: mitochondrial health. Your mitochondria are not just tiny powerhouses inside your cells. They are the biological engines that decide how much energy you can produce, how efficiently you recover, and even how well your muscles respond to exercise and nutrition. The problem is that with age, these mitochondria do not just slow down, they begin to malfunction. And when that happens, you experience fatigue, poor endurance, slower recovery, and accelerated muscle loss. Here is what is happening at the cellular level. Each muscle fiber contains thousands of mitochondria that convert nutrients into ATP, the energy currency of your body. But over time, oxidative stress, nutrient deficiencies, and inactivity cause mitochondrial DNA to become damaged. When that happens, those tiny engines start leaking free radicals instead of producing clean energy. This triggers inflammation, increases insulin resistance, and weakens muscle tissue from the inside out. Researchers call this process mitochondrial dysfunction, and it is one of the root drivers of sarcopenia. The good news? Mitochondria are not static, they can regenerate. Through a process called mitochondrial biogenesis, your cells can actually create new, healthier mitochondria. And there are very specific signals that trigger this process. Number one is exercise, especially resistance training. When you lift weights or even use your own body weight, you create microstress inside your muscle fibers. This stress activates a molecule called PGC1-alpha, the master regulator of mitochondrial biogenesis. Think of it as your body's mitochondrial reset switch. Number two is nutrition, particularly nutrients that enhance mitochondrial efficiency. Coenzyme Q10, found in foods like sardines and mackerel, plays a critical role in the electron transport chain, the inner machinery that turns food into ATP. Omega-3 fatty acids, especially DHA, stabilize mitochondrial membranes, keeping them flexible and efficient. And then there is whey protein, which we discussed earlier. Its cysteine content fuels glutathione synthesis, protecting mitochondria from oxidative damage. Combine that with polyphenol-rich foods like blueberries, pomegranates, and green tea, and you give those mitochondria both the energy and the shield they need to thrive. Let me give you a simple analogy. Imagine your muscle cells as cities, and your mitochondria as the power plants keeping the lights on. With age, some power plants get damaged and produce less electricity. But through resistance training, adequate protein, and targeted nutrients, you are not only repairing those plants, you are building new, upgraded ones that run cleaner and stronger. A fascinating study published in Cell Metabolism found that older adults who combined strength training with omega-3 supplementation increased their mitochondrial density and muscle protein synthesis, significantly, essentially rejuvenating their cellular engines. If you are finding this helpful, and of course subscribe if you want more deep dives into nutrition and longevity science. The bottom line here is simple. Muscle health is energy health. When you protect and regenerate your mitochondria, you are not just preserving strength, you are slowing the biological clock itself. When we talk about muscle loss with age, most people think it is purely a problem of exercise or protein intake. But one of the most powerful and least understood forces behind sarcopenia is inflammation. Not the kind that happens when you cut your finger or catch a cold, but a quiet, chronic, internal inflammation that builds up year after year. Scientists now call it inflammaging, a constant low-level fire that weakens tissues, disrupts metabolism, and blunts your ability to grow or repair muscle. Here is what is happening at the cellular level. Chronic inflammation interferes with two key signaling systems: the mTOR pathway, which builds muscle, and the insulin signaling cascade, which allows nutrients like glucose and amino acids to enter your muscle cells. When inflammation is high, both systems become resistant. It is as if the muscle cell doors are closed, the nutrients are there, but they cannot get inside. Over time, this creates a metabolic state where your body is technically eating enough, but your muscles are starving. The main culprits driving this inflammation are not mysterious. They include excess visceral fat, poor sleep, chronic stress, high blood sugar spikes, and diets low in anti-inflammatory nutrients. But here is the hopeful part. Inflammation is not permanent. It is highly responsive to lifestyle and nutritional choices. Imagine your muscles as a sponge. When inflammation is high, that sponge is stiff and dry. No matter how much water you pour, it cannot absorb. But when you cool the inflammation and restore insulin sensitivity, the sponge becomes flexible again. The same nutrients that once passed by now soak in, feeding the muscle from within. So how do we restore that flexibility? First, through anti-inflammatory fats. Omega-3 fatty acids, especially EPA and DHA, found in salmon, sardines, and anchovies directly reduce cytokines such as interleukin-6 and tumor necrosis factor alpha. Several studies, including those in the American Journal of Clinical Nutrition, show that older adults who consume omega-3 rich diets experience greater muscle protein synthesis and reduced muscle loss. Second, through phytonutrients. Compounds in turmeric, ginger, green tea, and deeply colored fruits and vegetables reduce oxidative stress and modulate inflammatory pathways like NF-kappa B. Adding turmeric with black pepper, for example, enhances the bioavailability of curcumin by up to 2,000%, amplifying its anti-inflammatory effects. Third, by controlling blood sugar. Every time glucose spikes dramatically after a meal, it causes a burst of oxidative stress that inflames tissues and accelerates insulin resistance. By combining protein and healthy fat with carbohydrates, or using whey protein before a meal, you can flatten those spikes and protect your muscle cells. A landmark study from Diabetologia showed that improving insulin sensitivity through diet and exercise restored anabolic responsiveness in older adults, meaning their muscles started responding to protein again, just like they did decades earlier. This is the power of restoring metabolic flexibility. When inflammation and insulin resistance fall, your body shifts from a storage state to a rebuilding state. Energy starts flowing toward repair, and protein synthesis can finally do its job. So the next time you think of muscle loss, remember it is not just about eating more protein or lifting weights. It is about cooling the internal fire that keeps your body from using that protein effectively. The bottom line? Muscle growth begins where inflammation ends. Once you calm that internal fire, the body's ability to rebuild, repair, and regenerate comes back online, and strength naturally follows. If there is one universal law in biology, it is this: the body grows through challenge, not comfort. And that principle becomes even more important after 60. Because while many people try to protect themselves from every kind of stress-avoiding exertion, skipping workouts, or staying within their comfort zone, their cells are quietly forgetting how to adapt. This is where the concept of hormesis comes in. Hormesis is the idea that small, controlled doses of stress actually make your body more resilient. Whether that stress is exercise, fasting, heat exposure, or cold therapy, each one triggers a wave of beneficial cellular responses that improve repair, regeneration, and longevity. When you challenge your muscles through resistance training, sprint intervals, or even brisk walking with added load, you create micro-tears in the muscle fibers. That may sound harmful, but it is the signal your body needs to rebuild stronger tissue. Those tiny micro-injuries activate satellite cells, the stem cells of your muscles. These satellite cells fuse with existing fibers, donating their nuclei and expanding the muscle's capacity to grow and regenerate. At the same time, this mechanical stress activates a molecule called AMPK, the cellular energy sensor. When energy levels drop during exercise, AMPK switches on processes that increase mitochondrial biogenesis, improve insulin sensitivity, and enhance fatty acid oxidation. In simple terms, every time you move beyond comfort, you are teaching your body how to use energy more efficiently and resist the decline of aging. Now let us connect this to other forms of hormetic stress. Cold exposure, such as a cold shower or brief ice bath, triggers norepinephrine release, which increases focus, reduces inflammation, and even stimulates the production of brown fat, the metabolically active fat that burns calories to generate heat. Heat exposure, such as sauna use, raises levels of heat shock proteins, specialized molecules that repair damaged proteins inside your cells and protect against age-related breakdown. Studies in experimental gerontology show that older adults who regularly use saunas experience lower inflammation, better cardiovascular function, and improved muscle recovery after exercise. Let me give you a simple analogy. Imagine your cells as students in a classroom. If they are never tested, never challenged, and never pushed, they forget what they have learned. Hormesis is like giving them regular pop quizzes. Each mild stress teaches the cells to adapt to repair damage faster, to clean up waste more efficiently, and to grow stronger from the experience. And perhaps the most important form of hormetic stress is resistance training. You do not need heavy weights or complex machines. Even body weight movements, squats, push-ups, resistance bands are enough to activate these powerful adaptive pathways. Research in the journals of gerontology has shown that adults in their 70s who perform resistance exercise 2 to 3 times per week can double their muscle protein synthesis rate and increase mitochondrial enzyme activity by over 50%. Here is the key takeaway. It is not about avoiding stress. It is about choosing the right kind. The difference between harmful stress and healing stress is recovery. By giving your body adequate sleep, nutrient-rich meals, and hydration, you transform those stress signals into regeneration. So the next time you feel the burn in your muscles, the chill of cold water, or the heat of the sauna, remember those sensations are not signs of damage. They are signals of adaptation. Your cells are learning to survive better, to thrive longer, and to fight aging from within. If you want to build muscle, you already know that protein and exercise matter. But what if the timing of those things matters just as much? Because emerging research now shows that our muscles, just like our brain and liver, follow their own internal circadian rhythm. And when you eat, sleep, or move at the wrong times, you are essentially sending mixed signals to your biology. The result? Slower recovery, weaker protein synthesis, and accelerated muscle loss. Here is what is happening at the cellular level. Every muscle cell contains a group of clock genes, molecular timekeepers, that regulate when energy should be produced, when protein synthesis should peak, and when repair should occur. Under normal conditions, these clocks are synchronized with light, food intake, and activity. But with age, and especially with irregular sleep or late-night eating, those rhythms drift apart. When your circadian rhythm is disrupted, the master clock in your brain, the suprachiasmatic nucleus, falls out of sync with the clocks in your muscles. That misalignment blunts the anabolic response to food. In other words, you could be eating enough protein, but if it is at the wrong time, your body cannot use it efficiently. Let me give you a simple example. Imagine your muscle cells as construction workers. During the daytime, they are fully staffed and active, ready to build and repair. But late at night, most of them are gone. If you send in materials at midnight, meaning you eat a heavy meal before bed, those materials just sit there unused. Timing your nutrients with your body's natural rhythm ensures that the right resources meet the right workers at the right time. So how do we align our eating and sleeping patterns for optimal muscle and metabolic health? Number 1, front-load your protein. Studies in the Journal of Nutrition show that protein consumed earlier in the day, particularly at breakfast and lunch, results in higher rates of muscle protein synthesis than the same amount eaten at dinner. That is because your metabolic rate and insulin sensitivity are highest during daylight hours. A morning meal with 30 grams of protein primes your body for repair and energy throughout the day. Number 2, respect the overnight fasting window. Giving your digestive system at least 12 to 14 hours of rest between your last meal and breakfast helps regulate circadian rhythm, reduce inflammation, and improve insulin sensitivity. That overnight fast also allows the body to focus on cellular cleanup, a process known as autophagy, which removes damaged proteins and mitochondria, paving the way for stronger, newer ones. Number 3, prioritize sleep as your muscle recovery drug. Deep sleep is when the body releases the majority of growth hormone, the signal that triggers muscle repair and fat metabolism. Even one night of poor sleep can reduce muscle protein synthesis by up to 20%, according to data from the Journal of Clinical Endocrinology and Metabolism. Good sleep is not a luxury. It is the foundation of physical regeneration. Number 4, train your body in sync with light. Exercise in the morning or early afternoon, when your core temperature, blood flow, and mitochondrial activity are naturally higher. Training late at night can delay melatonin release and disrupt sleep quality, reducing the very recovery that makes your workouts effective. When your eating, sleeping, and movement rhythms are in sync, something powerful happens. Your hormones, insulin, cortisol, melatonin, and growth hormone, Align in a coordinated dance that supports repair rather than breakdown. The takeaway here is simple but profound. You do not just feed your muscles with protein, you feed them with timing. Every bite, every rep, and every hour of sleep sends a message to your circadian biology. If that message is clear, your body builds strength effortlessly. If it is chaotic, your body stores fat, loses muscle, and ages faster. So if you have been focusing on what to eat and how to train but still feel sluggish or weak, it may not be your diet, it may be your clock. Align that, and your body will start working with you again, not against you.